In this video, we are going to go over how to calculate pH, pOH, H+, and hydroxide concentrations. And there's a lot of different formulas. It's very easy to get these confused at first. So let's try to buckle in and see how this makes sense. So on the back of your formula sheet, you will see different formulas. And these formulas are very important, and there's a picture down here to show you how to convert between all of them. pH is a measure of the acidity of your solution, and its formula is pH equals minus log whatever the H plus concentration is. So brackets, if you remember, that means molarity. pOH is equal to the negative log of the hydroxide concentration. You may know that if I take pH and pOH and I add them together, I get 14. If you've taken Algebra 2, you may know that the inverse of log is 10 to the power. So the inverse of negative log is 10 to the minus pH. And that will solve for H+. And if I want to solve for hydroxide, I can take 10 to the minus pH. And then lastly, hydroxide concentration times H+ concentration, that equals something called Kw. And Kw is equal to 1 times 10 to the minus 14. Okay, a lot of formulas here. It's very easy to get these confused until we start practicing. You want to be able to convert between each of these variables. All of these are going to be on your formula sheet, and this is a helpful graphic to show you that if you're given H+, you can't just go to pOH. There's a process. You go to pH and then 14 minus pH. Okay, so try to understand how this graphic works. And how I like to do this is I like to get to pH as soon as possible, because pH is something that I'm familiar with, and so it makes it a little bit easier for myself. So let's see how this works. In this first one, which I'm going to number 1, we're given pH, and we want to figure out the pOH, the H+, the hydroxide, and whether it's acidic, basic, or neutral. If you remember from our very first notes, pH greater than 7 is basic, pH less than 7 is acidic, and then a pH at 7 is what we call neutral. Okay, so because this pH is greater than 7, I know that I have a basic solution. So I'm going to look at my formula sheet, and I'm going to see how I get pOH. And I can go pH to pOH using this formula. So I will say 14 minus pH equals pOH. 14 minus 11.93. And I get 2.07. Now, I want to get H+. Well, if I'm at pH and I want to get H+, here is the conversion I have to do. 10 to the minus pH equals H+. So in my calculator, I'm going to do 10 caret the negative 11.93, and that will give me my H+ concentration, or my molarity. And I'm always expecting like a decimal and a small number here, just so you know. I get 1.17 times 10 to the minus 12. And that unit is molarity. To get the hydroxide concentration, I'm going to take 10 to the minus pOH. And that gives me hydroxide. So I'm going to take 10 to the minus 2.07. And when I do that, my calculator's in scientific notation mode. I get 8.51 times 10 to the minus 3. Okay, so that's how you do one of these. On number 2, how do you do it if you're given H+ to start out with? Well, My gut is get to pH as soon as possible. So let's see what we have here. We are given H plus. We want to get to pH. So the way we do that is we use the formula negative log of H plus. So I'm going to say negative log H plus equals the pH. The negative log of 3.45 times 10 to the minus 5, that will equal pH. I'm going to plug that into my calculator, and I get 4.46 as my pH. Because my pH is less than 7, I know that I have an acidic solution. To get POH, I'm going to take 14 minus pH. So 14 minus 4.46, I'm going to get 9.54. And then to get the hydroxide concentration, I'm going to take 10 to the power of the minus POH. That'll give me hydroxide. So 10 to the power of negative 9.54. And I'm going to get a small number. I always expect kind of small numbers here. 2.88 times 10 to the minus 10. If I'm neutral, my pH is 7, which means 14 minus pH equals POH. So 14 minus 7 equals 7. I take 10 to the minus 7 equals H plus. So I get 1 times 10 to the minus 7, and that 1 is not necessary. You could just say 10 to the minus 7. And then 10 to the minus 7 equals hydroxide. And we get 1 times 10 to the minus 7, and this is molarity, molarity, molarity. That was number 3, not a terrible one. Let's just do a couple more, number 4. Here we're given hydroxide. Again, I want to try to get to pH as soon as possible. There's lots of ways to start this one, so I'll show you the way I think is easiest. We're going to take POH, and that equals negative log of hydroxide. We are given the concentration of hydroxide over here, so that's why I would like to use that. POH equals the negative log of 5.8 times 10 to the minus 2. And when I plug that into my calculator, I should expect to get 1 point something. And I get the POH equals 1.24. Now, 14 minus the pH equals, the POH, I should say, equals the pH. So I'm going to take 14 minus 1.24. And I get 12.76. And if you are wondering, pH and POH do not have any units. To get H plus, I'm going to take 10 to the minus pH. So that'll be 10 to the minus 12.76. And again, I expect a small number. I get 1.73 times 10 to the minus 13 molar. Now, looking at my pH, it's above 7, so I know that I have a basic solution. Okay, last one for this video. On number 5, we are given the POH. Again, I think a good strategy is to get to pH as quickly as possible. We have 14 minus POH equals pH. So I'll take 14 minus 9.3. And when I take 14 minus 9.3, I'm going to get 4.7. So 4.7 is my answer. That's less than 7. That'll mean that this is an acidic solution. I'm going to take 10 to the minus pH to get H plus concentration. So 10 to the minus 4.7. I get, in scientific notation, I get 1.995. So basically 2 times 10 to the minus 5. And I take 10 to the minus POH to get my hydroxide concentration. So 10 to the minus 9.3. and I get 5.01 times 10 to the minus 10. Okay, so try out the rest of these and then check with your answers online. You'll have to be able to solve for pH on a quiz or test, so it's pretty important, and it's something that we do a lot in this unit.